Okay, in this video we're going to be concluding our discussion on systems of equations, and we'll be employing Cramer's rule. Cramer's rule, it states that if you have a system in this form, ax1 plus by b1y equals c1, a2x plus b2y equals c2. It's just we've written both of these equations in standard form with some non-zero coefficients here for the x and y and constants over here. In fact, these could be 0 on this side. The solution will be given by x is going to be d sub x divided d, and y is going to be d sub y divided d, and this d down here, this is a disclaimer you will see in many math procedures. You cannot divide by 0, so this determinant d can't be 0. What is this d sub x and d sub y and d? Well, they are our determinants from the previous section. All right. D, this denominator here, is the determinant that involves only the coefficients. Look here, a1 and a2, a1 and a2. b1 and b2, b1 and b2. So D is often called the coefficient matrix. It is the determinant of the matrix that is simply the coefficients of the x and y. Well, this D sub x, all we've done is notice b1, b2 remain the same. That is, the y's stayed the same. But when we're finding the x coordinate of the solution, we have taken the constants, the equal to part, and replaced for this x part. One more time. The difference between this one and this one, notice that the y column stayed the same. But here, since we're solving for x, we have replaced the x coefficients with the constants here. Well, likewise, for d sub y, this time the x coefficient stayed the same, but we have replaced the y coefficients with the constant. Perhaps it looks a little confusing, but you'll see when we do an example that it's not too bad at all. Let's skip right on in to our assignment. The assignment for this section is going to be page section 7.4, section 7.4, page 522. 1 through 19 odd. Okay. All right, let's begin with problem number 1. Number 1 on page 522 gives us the system 2x minus 3y equals 3, 4x minus 2y equals 10. All right. To solve this system, we're simply going to find each one of these values. This value d is the determinant of our coefficients. So d equals the determinant of my coefficients. 2 and 4 in this column, negative 3, negative 2 in this column. All right. Well, our determinant is multiplying these two together, 2 times negative 2, and subtracting these two multiplied together, 4 times negative 3. Well, 2 times negative 2 is a negative 4, and then negative times negative is essentially a positive here, so we have negative 4 plus 12. That is a positive 8. Okay, that is the determinant of our coefficient matrix. D is a positive 8 here. Next, I'm going to find d sub x. D sub x. Well, it's the same matrix, but instead of my x column, I'm going to substitute the equal to part. So 310, the constants go in the x. The y's stay the same because we're seeking the x coordinate. Well, 3 times negative 2. Subtract 10 times negative 3. This is negative 6 plus 30. That's 24. That is my d sub x. All right, lastly, d sub y. Well, this time the x column will stay the same. This 2, 4 remains. That's my x coefficients. And instead of my y, I will replace with the equal to part, 3 and 10. So this will equal 2 times 10. 2 times 10, subtract 4 times 3. This is 20 minus 12, and this is 8. All right, so we're now ready to find both the x and the y. So my x will equal x equals d sub x divide d. So d sub x is 24. D is 8. 24 divided 8 is 3. 3 is the x coordinate of my solution. The y is going to be d sub y divide d. D sub y is 8. D is 8. 8 divided by 8 is 1. So we're left with a solution 3, 1. 3, 1. This is our solution. Let's take this and substitute it in my original to see that it works. 2 times 3 is 6. Minus 3 times 1 is 3. 6 minus 3 is indeed 3. Substituting 3 in place of x. 4 times 3 is 12. Minus 2 times 1 is 2. 12 minus 2 is 10. We see this ordered pair satisfies both. 3, 1 is the solution to the system. Okay. All right, a couple of notes about Cramer's rule. 1, if d does equal 0, if d equals 0, then there will not be a unique solution. It might be a no solution case, it might be an infinitely many, okay? We'll have to do some further investigating. All right. So that is question number 1. All right, I'm going to skip down and do one that is a 3x3, but I'm going to do one that is not on your assignment, so that you're left with those. So I'm going to do number 14. Okay. 14, they give us negative x plus y plus 3z is equal to 6. X plus y plus 2z is 7. And 2x plus 3y plus z is 4. All right. So this time we're going to have to find 4 components. We're going to find a dx, a d, a dx, a dy, and a dz, but it's going to be in the same form as the previous one. All right, d, our coefficient matrix, is going to be negative 1, 1, 2, negative 1, 1, 2, 1, 1, 3, 1, 1, 3, then 3, 2, 1, 3, 2, 1. All right. Now we go through these diagonals. Negative 1 times 1 times 1. I'm gonna simply do this multiplication in my head. Negative 1 times 1 times 1, that's negative 1. Plus 1 times 2, and then picking up this 2. 1 times 2 is 2, times 2 more is 4, plus 4. Then lastly, 3 times 3 times 1, that's 9. Okay. Now minus all of these diagonals. 2 times 1 times 3, that's 6. Minus 3 times 2, that's 6. Times a negative 1 is negative 6. Minus a negative 6. Subtract 1 times 1 times 1, that's 1. Well, minus a negative 6, that becomes plus. So negative 1 plus 4 is a 3, plus 9 is 12. 12 minus 6 is 6, plus 6 is 12, minus 1 is 11. Alright, that is our D matrix. Now looking at D sub x. Sub x, we're going to substitute in place of my x column my equal to 6, 7, 4. 6, 7, 4. The rest remains the same. 1, 1, 3. 3, 2, 1. Okay, finding this determinant. 6 times 1 times 1, that's 6. Plus 1 times 2 is 2, times 4 more is 8. Plus 3 times 3 is 9, times 7 is 63. Subtracting. 4 times 1 times 3 is 12, minus 3 times 2 is 6, times 6 more is 36, minus 1 times 1 times 7. Alright. 14 and 63 is a 77, minus 12 is a 65, minus 36 is a 29, minus 7 is a 22. Okay, now I want dy. The x stays the same, negative 1, 1, 2. The y, we will change to the equal to part, 6, 7, 4. And the z stays as 3, 2, 1. Okay, I'll leave this arithmetic to you, but the result will be negative 11. Alright, dz. The x column remains the same, negative 1, 1, and 2. The y column remains the same, 1, 1, 3. The z column, I take my, what used to be 3, 2, 1, the z coefficients, and replace with my constants, 6, 7, 4. Alright, this will be 33. Alright, so to find each one of my coordinates of my solution set, x is going to be d sub x divide d. So in this case, 22 divide 11, that's 2. Y is going to be d sub y divide d, and that is negative 11 divide 11, that's negative 1. And z is going to be dz divide d, that's 33 divide 11, and that is 1. So I record my solution as the ordered triple, 2, negative 1, and 1. And if you substitute that into the original, you'll see it satisfies it. Alright, I'm now going to give you the answers to the problems. As you can see, there's a lot of arithmetic involved, so you don't want to just run off and do the whole thing if you make one little small error. So, solutions. Solutions to page 522, 1 through 19 odd. Number 1 we already found was 3, 1. Number 3 is no solution. So when you do number 3, you should be on the lookout for d being equal to 0 here. That is, the coefficient matrix will be equal to 0. Number 5. negative 15/43, comma, negative 27/43. 7. (60/43). Interesting that that denominator is also 43. 46/43. It should give you an idea of what the coefficient matrix is going to look like. Number 9. 2, 0. Number 11. 474 over 323. 40 over 323. 13. 002. Negative 2, I mean to say. 15. 1/2. 5 over 2 and 1. Number 17, no unique solution. So this will be similar to number 3, in that the determinant of the coefficient matrix will be 0. Number 19, final problem, negative 10/91, negative 9/13, and 107/91. With this, you should be able to handle all the problems on page 522.